Most AI memory benchmarks treat agents like personal diaries. But in hospitals, enterprises, or shared households, memory isn't private. It's a common pool queried by multiple principals under different roles and scopes. High recall without strict governance isn't an achievement. It's a security vulnerability. If an assistant discloses a patient's diagnosis to an unauthorized family member or recovers a deleted confidential draft, the system has failed. That's why researchers introduced GATEMEM, a benchmark treating memory as a coupled governance problem. Instead of measuring recall in isolation, GATEMEM evaluates three dimensions simultaneously: authorized utility, contextual access control, and agent-facing active forgetting. It evaluates 91 multi-party episodes. At each hidden checkpoint, the agent receives the interaction history, the requester's authenticated identity and policy context, but never sees the grading rubric or protected targets. Technically, responses are normalized into 4 discrete actions: answer, answer redacted, refuse, and no memory. This cleanly separates partial disclosure from refusal and deletion compliance from authorization limits. The benchmark probes for soft overreach attacks like indirect inference, cross-patient confusion, and update-delete conflicts. Performance is captured via a multiplicative memory governance score. Utility multiplied by 1 minus access violation rate, multiplied by 1 minus forgetting failure rate. This structure enforces a hard constraint. Severe leakage or post-deletion recovery cannot be compensated by high utility. Across 6 frontier backbones and 7 baseline architectures, no method simultaneously optimizes all 3 pillars. Long context prompting achieves the highest governance scores, but incurs massive token overhead and still suffers non-negligible leakage. Policy-aware retrieval reduces unauthorized disclosure, but frequently paralyses legitimate queries through overrefusal. Even dedicated memory systems like MEM0 or REMEM fail to generalize, because structural memory organization does not automatically enforce contextual boundaries or behavioral non-recoverability. Current memory agents remain far from reliable shared deployment. Until we treat memory as a governed shared state with verifiable access and deletion semantics, institutional AI will remain brittle. Code, dataset, and leaderboard are open. If you're building persistent agents, GATEMEM is the new standard for testing real-world reliability.